Hello 8th class students. Now we are going to start the chapter reflection of light at plane surfaces. So light, actually this chapter is very big and plays an important role because the continuation of this chapter will be there in the 9th class and again in the 10th class. But in 8th class you have very basic knowledge of this particular chapter. So I am going to cover up the chapter on the whole, like you will get the knowledge of 9th and 10th as well. Those topics also we will be discussing in this particular chapter, but we will not be going at a stretch. We will be giving priority to the 8th class syllabus first, okay, but there will be a very slight extension of these topics in our later on classes. So watch these videos. First I am going to provide you with the animation versions, then as usual we will be going with the textbook explanation, then question and answer discussion from the workbook. In these three formats we are going to cover this chapter. Thank you.
Hello friends, this video on Light Part 2 is brought to you by examfear.com. No more fear from exam. Now, when we talk about seeing objects, so we need to talk about two types of objects, that is luminous objects and illuminated objects, because these are the objects that we can see. Now, please remember that it is not that we are able to see all the objects which are present around us. There may be many such objects which are present, but we are not able to see them. Do you know why? Because they do not fall under any of these two categories, because we can see only luminous and illuminated objects. So let us see, what do we mean by luminous and illuminated objects? So luminous objects are those objects which produce their own light. So these objects generate light. For example, any example that comes to your mind instantly? Yes, exactly. Sun. Sun is a classic example of a luminous object because sun has its own light, right? So we can see luminous objects because they are the ones which are producing light. So a light is present there and we have our eyes which are functioning and we have a brain, so we can actually see that object and we can also perceive what we are seeing. So luminous objects are those objects which have their own light and they can be seen. The second category, that is illuminated objects. So these objects, they do not produce their own light. Now you might say that when these objects are not producing their own light, then how can we see them? Because in absence of light, we do not see. But these objects have a special property that they are capable of reflecting light to our eyes coming from luminous objects. So these luminous objects will be producing light. But there are certain objects which are called illuminated objects. They have this property that they can reflect the light which was produced by the luminous objects to our eyes. And whenever reflection of light happens and it reaches our eyes, we are able to see that object. So let us take an example of anything. Let us say a bottle of water which is lying on the table. Why were we able to see that bottle of water? Because the light which is falling on the bottle of water, the bottle is able to reflect that light. Now that doesn't mean that the light is being produced by the bottle. Light is being produced by some other source. The light might be coming from the sun. Maybe the bottle is kept outside and it is having exposure to sunlight. The light might be produced by the bulb present in that room or the tube light present in that room, or maybe a candle. So it is not necessary that the object, in order to be viewed by a person, needs to produce its own light. It can also reflect light which is produced by some other object. So the best examples of luminous and illuminated objects from nature would be the sun and the moon. So if you look at the sun, so the sun produces its own light. So sun is a luminous object. But if you look at the moon, do you think moon has its own light? No, moon doesn't generate any light of its own. But what it does is it reflects the light which is produced by the sun. And that is why at night also, if you observe closely on a full moon day, you will see that the moon is also actually producing a lot of light. But that is not actually produced by the moon. It is just the light which is produced by the sun but is reflected by the moon. So moon is an example of illuminated object. So these are some of the examples from nature. Now, if you look at a daily life, the light is produced by the sun. But why are you able to see this house? Because the house is able to reflect light. The house is not producing any light. Why are you able to see the tree? Because the tree is able to reflect light. It is again not producing any light of its own. Now, if you look at examples of luminous objects other than sun, also you have many other examples of luminous objects like fire, flame, lamp, bulb. All these are examples of luminous objects. And illuminated objects, most of the things which we are able to see, for example, wood, table, chair, glass, utensils. So all of these are illuminated objects, anything that we are able to see. But we know that they are not producing their own light. They all fall under the category of illuminated objects. So whenever we talk about what we can see and what we cannot, so we can see only the luminous and illuminated objects. Now those objects which neither produce their own light nor do they reflect the light produced by some other object, those objects cannot be seen by us, because in case of those objects there is real absence of light and we cannot see in absence of light. So in this lesson, we are going to talk about how do we see things in presence of light. How do we see images of stuffs? Like when you stand in front of the mirror, you are able to see yourself in the mirror. So how is that image formation taking place? You would have often seen elderly people wearing spectacles. They use lenses. So we will see what are those things, what are lenses, what are spectacles. There are many different types of mirrors, like plane mirrors, spherical mirrors, which are used in different types of things. Like in car you have rear view mirror, for shaving you use a different type of mirror. We will also talk about you would have seen the application of these phenomenon of light in these optical instruments like lenses, glasses, mirrors, the lenses which are used in your camera, or the microscope and the telescope. So everywhere you see application of these phenomenon of light. So here you see a bent pencil when it is put inside water. So do you know why this bending happens? This also happens due to refraction of light. However, we will talk about refraction in our higher classes. So today we will talk about reflection of light. So there are a lot of phenomena associated with light, due to which we see so many different, so many beautiful and different natural things. One such interesting example is the rainbow. Formation of rainbow is also nothing but a magical property of light. It is due to dispersion of light. So with this, let us start with what is light. So we can see objects in presence of light. So light is nothing but a form of energy which enables us to see things around us. So by now you already know that how important light is to make us see things, because if there is no light we will not see anything, and it is an energy. So it is in the form of energy, and that is why you would have seen that light energy can be converted into other forms of energy as well. Light travels along straight path. It always travels along a straight line, and that is why, now you might say that how do you know that light travels along straight path? So can we see light traveling along straight path? Well, if you talk about normal sunlight, you can actually try to observe it. You know how? Just try to observe the rays of the sun coming inside your house through a tiny hole. If a tiny hole is present on the window, and if you see the sun rays are coming through that hole, or a very thin slit, so you can actually see that the rays of the sun are in the form of straight lines. So that is one way you can observe it. Now we know that they travel along straight path, because had light been traveling in curved paths, then there would have been no shadow formation. Why do you have shadows? Because whichever place is blocked by light, so whenever you keep some object which doesn't allow light to pass through it, so just behind that object you see shadow. So that happens because light cannot take a curve and travel towards the back of that obstacle. So that these are some of the things by which you can say that yes, light travels along straight path. So we will also try to see it using a very simple experiment. The speed of light is measurable and it is 3 into 10 to the power 8 meter per second. Now till now we have also learnt about another form of energy, that is sound. So in case of sound, we saw that the speed of sound is very less when compared to the speed of light. Speed of sound is around 330 meter per second, whereas speed of light is 3 into 10 to the power 8 meter per second. So there is a huge difference, and due to these differences between the speed of sound and light, you get to see the lightning first and then you hear the sound of the thunder. So that's because of the differences in their speeds. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again. Hello friends, this video on Light Part 3 is brought to you by examfear.com. No more fear from exam. So now let us try to prove that how do we know that light travels along straight path. So for that we will make use of very simple things. We'll make use of the playing cards. I am sure this would be available in your houses. If it is not there, you might use sheets of paper, cut it like this. And what you need to do is you have to make holes at the center of each of these cards. So as you can see, there are holes at the center of each of these cards. Now arrange these cards in such a way that the holes of all the 4 cards are along a straight line. As you can see here, all the holes are along the same straight line. Now what do? Now you take, if you have a laser, then that is the best, because in laser you can actually see the light ray coming out. So if you flash light through a laser, in case you do not have a laser, not a problem, you can also use a torch or a candle. So anything you can use here such that the ray of light from that source, it passes through all these 4 holes. Right? Now how do you know that the light is actually passing through all the 4 cards? For that purpose, you observe that the light reaches the wall. So make sure that you are doing this experiment in at such a place where you have a wall behind the 4 cards. The wall or a screen or anything behind that. So what you will see is the light which is coming out of this laser, let us suppose it is red light. So the same red light will be seen on this wall, which shows that the light actually passed through all the 4 holes on the cards. Now, that doesn't prove that light is traveling along straight path. To prove that, what are we going to do next? You just try to move the second card a bit. So you have moved the second card, right, in such a way that this hole is no more along the straight line as the other 3 cards. Now this time what do you observe? You observe that there is no light on the screen. That means light could not travel till here. So where did the light get blocked? The light got blocked at the second card itself, because the light came through this hole. It came here, but then the card is not allowing light to pass through it. So the light got blocked. So it could not go to the 3rd and the 4th card. Now, how does this prove that light travels along straight path? Because had light been traveling along curved paths, in that case, light would have taken this path and then again it would have flown like this. So in case it would have been traveling in curved paths, it could have traveled like this. But since light doesn't travel in curved paths, therefore it could not reach the wall. Right? So this proves that light always travels along straight path. In fact, you would observe it, the rays coming from the sun during morning through your window. So if you just do not keep the entire window open, in that case you cannot see the ray of light. But if you just leave a small slit or a small hole and try to observe the light coming in, you will be able to observe the straight path there also. Now I have often been using the terms ray of light. So what is ray of light? Now, ray of light is a straight line path of light. So, as I said, light is always traveling in straight path. But one single line of light or one single part of light is called a ray of light. And in diagrams, it is often represented like this. But we also use the term beam of light in many of the cases. Now, what do we mean by beam? So, beam and ray, do they mean the same thing? Not really. When I say beam of light, it means bunch of rays of light. Now, see, when you receive the light from the sun, do you think it is just one ray of light coming from the sun? No, it is like bunch of rays, a lot of rays coming together, and that's how you get so much of light from the sun. Forget about the sun. Even if you consider the light coming out of the electric bulb, so that also is not just one single ray of light. So whenever light is actually coming out from a source, it is always like a bunch of rays of light. Then that bunch is referred to as beam of light. So when you have too many rays of light coming together, that is called beam of light. Now, throughout this lesson, since we are going to talk about light, I will be often using the term ray of light, which would mean that the path of light, it is coming from source and it is falling on some object and all. But I wanted to make the distinction between ray of light and beam of light clear before I go ahead with the lesson. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again. Hello friends, this video on Light Part 5 is brought to you by examfear.com. No more fear from exam. So now we will try to understand the laws of reflection. Now we understood that okay, whenever light falls on the surface, it bounces back. That bouncing back is reflection. But how exactly reflection takes place? There are certain rules, there are certain laws which govern the phenomenon of reflection. So let us look at the laws. There are two important laws of reflection. First one says that the incident ray, reflected ray and normal. So all these three rays which we talked about just now, that is incident ray, reflected ray and normal, all of them lie on the same plane. So that is the first law of reflection. That means these three lines, 1, 2 and 3, they are going to lie on the same plane. What do we mean by a plane? Plane would be something like, let us say, a sheet of paper. So if all the lines are lying on the same sheet of paper, we say that they are on the same plane. Wall is a plane. If all the three lines are lying on the wall, that means they are on the same plane because wall is one plane. But whenever you talk about something like a box, maybe a cuboid, so then it has got many planes, but each surface is one plane. So this is the first law. Second law says that the angle of incidence is equal to the angle of reflection. That is, this one is angle of incidence and this one is angle of reflection. So as per this, angle I is equal to angle R. So now these are going to be the most important concepts of reflection. Because based on this, we will be able to understand how reflection of light is taking place from different surfaces, and using that we will be explaining a lot of stuffs like how is our image formed, how are we able to see different objects. We can explain all of them using these two simple laws of reflection. But before we do that, let's try to prove the laws of reflection. Why should you trust me that whatever I am saying is right? So let us try to prove the laws. Let us try to see how can we verify them. So for that, what you can do, if you want, you can try it out yourself also. It will be easier if you have a laser light, because with laser light, you can clearly see the incident ray and the reflected ray. And as I have already mentioned, the normal is an imaginary line which you will anyways not be able to see. So let us suppose this is one plane, which could be a sheet of paper, which could be any, it could be a glass surface, right? So if you take a glass surface or a mirror, that there you can see reflection at its best. So you take a mirror and then you put this and then focus light from the laser and you will see reflection taking place. So this is your incident ray and this is your reflected ray. Now what do? just let us try to draw the normal to this surface of the mirror, right? So this is normal. Now, using your protractor or your compass, whichever you feel like, try to measure these angles. This is angle of incidence and this is angle of reflection. So, and make a note of both the values. So, you will. Now, let us try to do one thing. What do we do? Now, let us change the orientation of the incident ray. So, basically, we are trying to change the angle of incidence. Now, since you just change the way the light was falling from the laser, so what happens? Now, your new angle of incidence is this. So, let us call it as I dash. So, initially we found that angle I was equal to angle R. Now, in this case, again, as soon as you spot the laser on the surface, you could easily see the reflected ray going out. So, let me call that R dash. So, here you will find again on measuring that I dash is equal to R dash. You further try to change the angle of incidence. It has decreased further, but at the same time you will also see that the angle of reflection has also changed. So basically this experiment proves that as you change the angle of incidence, the angle of reflection also changes, and in all the cases angle of incidence remains equal to the angle of reflection. So this is how we have proved one law of reflection. What about the second one? That is, all these three rays, incident ray, reflected ray and the normal, they all lie on the same plane. So for this I have made the arrangement a little different so that it becomes easier for you to understand the concept. So let us suppose that this is the wall, and on the wall you have mounted a mirror. So this is the mirror, right? And now this is your laser. So you have your laser somewhere here. So from here the incident ray is coming and it is striking the mirror, and from there it is getting reflected. Correct? Now what you have done is you take a sheet of paper below. So this is a top view. I am seeing it from the top. Just imagine I am seeing it from the roof. So this is how it looks like from above. But basically this is how the rays are, but you have kept a chart paper here. So this is your chart paper or white sheet of paper. Anything should be fine. Now what you have to do is, as you see the incident ray, just draw a line on the chart paper. Similarly, as you see the reflected ray, exactly at the same position, same orientation, draw a line which represents the reflected ray, and then you draw a perpendicular line to the surface, that is to the sheet of paper. So once you have drawn everything, just take this paper out. So the paper would look somewhat like this. The paper has the incident ray drawn, it has the reflected ray drawn, it also has a normal which is drawn, right? Now just look at these three lines. All these three, they lie on the same sheet of paper, which in itself proves that they are lying on the same plane. But still, if you want to experiment with this and you want to check whether they can lie in two different planes or not, then what you can do is just cut this piece of paper from this portion such that one ray doesn't remain here. So what do you see? I mean, anywhere in between these three rays, you cut the paper and try to create two planes. And you will see that you will not be able to see all of them on one plane, which proves that only on one plane you will be able to see all these three rays, that is, they all lie on the same plane. So if you try to change the plane, you will not be able to see all of them. So this simple experiment proves that all these three rays lie on the same plane and the angle of incidence is equal to the angle of the reflection. Now let us look at some examples which we see in our day-to-day life. Have you ever seen these kind of pictures? Now they are not only pictures, these happen in reality. In case you have gone to any of these places or places similar to this, you would have seen these kind of effects. So you have clouds in the sky, but you see the same clouds image in the water. So this happens due to reflection. Now you see this only when light is present. If there is complete darkness all around, you will not be able to see the image. right? Now what happens is cloud is not producing light. Light is produced by the sun. But that light, when falls on the cloud, gets reflected by the cloud, and because of that reflection, this image is formed. And the same is true for these trees as well. So these are some common examples of reflection. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again. Hello friends, this video on Light Part 4 is brought to you by examfear.com. No more fear from exam. So now we are coming to the first and the basic topic of light, that is reflection of light. So it is due to this reflection of light that you are able to see yourself on the mirror. You are able to see the images of so many different objects. So we are able to see all the things around us. So for all of these, reflection of light is responsible. So let us try to understand what it is. Reflection is bouncing back of a ray of light when it strikes a boundary between media through which it cannot pass. What does it mean? It means that light will always come from a source. So any object which is luminous, which is capable of producing light, so light will obviously come from that object. So how will the light come? It will come in the form of rays. Now when that ray of light is falling on some other object, or it is falling on some other boundary, some other object, some other surface through which it cannot go further, which doesn't allow the light rays to go further. So in that case, what happens? It bounces back from that surface, and that bouncing back is known as reflection. So just now in the previous example, you saw the example of playing card. Now as long as we provided the holes, that time light was passing through them. But when instead of the hole you play the playing card, so that doesn't allow light. So what happens? Light bounces back. So look at some of the examples or some of the applications where reflection of light takes place. Have you ever seen, if you have ever been near a river or a lake or a pond, and you would have seen that the images of the nearby objects are formed in the water. So how do you have this image formation? So see here, the hill. So there's just one hill which exists here. This one is the image of this hill which is formed in the water. You see yourself in the mirror. So you also see images of so many different objects. So from where do you get, this is just one object, right? But still you are able to see another object in the mirror. So how is that happening? That is all happening due to bouncing back of a ray of light. So let us assume, now what do I mean by different media? Media means anything, any object through which the light is traveling. For example, if light is coming from the sun, let us just a rough example. Let us say this is sun, and a ray of light is coming from the sun and it hits an object here. Okay, so this object is an opaque object. It doesn't allow light to pass through it. So what will happen? Light will bounce back. So this bouncing back. So basically you can say that light had struck a surface, light had struck a boundary which was between two media, because this medium was air, light was traveling through air in this case. But after it touched it, this is no more air. This is some object, maybe either wood, or it is glass, or it is metal, or something else. So the two different media, and this is the boundary. So as soon as it had struck the boundary, it was not allowed to go further. That's why it bounced back. So this bouncing back is called reflection of light. Now let us look at some of the important terminologies associated with reflection of light. Now, with reflection of light, the first thing that we want to understand is how image formation takes place. How do we see ourselves in mirror? How do we see the objects around us? Those are the basic things that we want to understand by knowing reflection of light. Now, in order to understand these simple concepts, we have to be aware of some simple things or some simple facts related to reflection. So, the first thing we should know is incident ray. What do we mean by incident ray? Ray, we already know it is nothing but a ray of light. Incident, the ray of light which strikes the boundary or the surface. That means this is that ray which is coming from the source of light, or it is not always necessary that it is coming from the source of light. It can either come from the source of light, that is a luminous object, or it can also come from some other object which is acting as a source of light. Correct? So from wherever the ray of light is coming and it is falling on the surface, that ray is called incident ray. So let us suppose this is a mirror. So mirror is nothing but a surface, because mirror is a boundary which is separating two medium. This side is air and this side is glass. So mirror is acting as a boundary. So this ray of light which falls or which strikes the boundary is called incident ray. The next one is reflected ray. Now as soon as the incident ray strikes the mirror, what happens? Mirror doesn't allow it to go further, so it bounces back. And so the ray which is bouncing back, that is called the reflected ray. So it is the ray which is sent back by the surface after reflection for a given incident ray. That means for every incident ray, there will be a corresponding reflected ray. Third is normal. What is normal? It is a perpendicular to the surface at the point of incidence. What is point of incidence? This point at which the incident ray strikes the surface. That is called point of incidence. So this is point of incidence. And normal is a perpendicular which is drawn to the surface. This is the surface, mirror is the surface, and this is the point of incidence. Right? Now this is an imaginary line, so normal doesn't exist in reality. So even if you try to understand, or if you try to see the reflection of light practically, you will not be able to see normal, because normal is a hypothetical line, it is an imaginary line. So why are we imagining such a line? Because knowing normal, we will be able to tell the direction or the inclination of the incident ray and the reflected ray. So we will get to know the significance of normal in a little while, but normal cannot be seen because it doesn't exist at all. So we have created it in our imagination to help us in understanding the concept of reflection. Next is angle of incidence, that is the angle between incident ray and normal. So this is the angle of incidence. And the angle of reflection, which is nothing but the angle between normal and the reflected ray. So this is the angle of reflection. Now why are these two important? Because these are the angles which actually tell us at what orientation the rays are striking a surface and they are getting reflected. So here normal acts as a reference which helps you to define these angles of incidence and reflection. Now we often denote normal with a capital N, and angle of incidence is denoted as angle I, angle of reflection is denoted as angle R. So basically normal divides the angles between the incident ray and the reflected ray. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again.